everyone. In Geometry Lesson 1-6, we learned about the midpoint and distance formula. I talked about the midpoint in a different video, but in this video we're going to focus on the distance formula, how to find distance between 2 points, and how it applies to the Pythagorean theorem. So our first question says, find the length of CD and EF and determine if they are congruent. And we've been given these two graphed segments. So what I'm going to do is I'm going to find the distance formula, and I'm going to show you two different ways to do it. First, the book gives us this lovely formula. It's the square root of x1 minus x2 squared plus y1 minus y2 squared. That is the technical distance formula. Now all I need to do is I'm going to take the two x values from CD and put them in where those x1 and x2 are. And it doesn't matter which one I make 1 and which one I make 2. I'm going to make it D x1 and 0, the C point, x2. Okay, and then I'm going to do the same thing with the y value. So I'm going to take the y value from here and subtract the y value from there. Now I need to follow order of operations. Okay, first I need to deal with what's inside the parentheses. So I get the square root of 4 minus 0 is 4, and that's squared, plus 2 minus 3 is negative 1, and that's squared. Now I have to square them, so I get 16 plus 1, and then I do the square root. And 16 plus 1 is 17, so this is the square root of 17 for that one. Okay, so that is the length of CD, and that's how you use the distance formula. Now, I gave you a shortcut or an acronym to help you remember how to do it. It's SSAS. Subtract, I'll just put a minus there. Square, I'll put a little 2 there. Add, and then square root. That is the acronym to help you remember the steps. So I'm going to use this on EF, and I'll show you how to find the distance using this. And I like this better. It's easier for me to remember, and it's a little less scary looking than this lovely formula. So all I need to do first is line up my points. So I'm going to do -1, 0, and -2, -4. Okay, so I just put one on top of the other, making sure that the x's are lined up and the y's are lined up. Now I'll subtract. Now you're not allowed to borrow with this subtraction, but you just say, okay, what is 0 minus -4? And you write down your answer. And then what's -1 minus -2? And you write down your answer. Okay, then you're going to square these results. Okay, so squaring them, I get 1 squared is 1, and 4 squared is 16. Then I need to add these together, and then I need to do the square root of that. So I got my square root. This is the distance from E to F, or F to E, and it is the same steps. You subtract first, which is what we did first here, subtract. Then you square, which is what we did next there. Then you add, which is what we did next there. And then it's the square root. But it makes it a little less intimidating when you look at it, because this just looks like a few math steps. This looks like a scary looking formula. Okay, now sometimes they ask you to determine if the segments are congruent, and the way you do that is you check this number inside the square root. If those numbers are equal, then yes, they are congruent. So these are congruent. Okay. Now, the next type of question, they said, use the distance formula and the Pythagorean theorem to find the length of AB if A is 4, 8 and B is -2, 6. Okay, so this was like number 18 through 20 on your homework. We should graph these. A is 4, 8, right here. B is -2, 6 right there. And I will connect them. So let me show you how to use the Pythagorean theorem to do this. And then we'll use the distance formula. So for the Pythagorean theorem, what you do is you count how high it goes. So if I was to make this into a triangle like that, I count the height here, and I just count the boxes. It's 1, 2. So the height here is 2. Okay? And then I count the length here. So it's 1, 2, 3, 4, 5, 6 boxes across. So this length is 6. Now I just need to apply the Pythagorean theorem to find this diagonal length, or C. So I have 6 squared plus 2 squared equals C squared. This is 36 plus 4 equals C squared. I just squared those. Now I can add them. 36 plus 4 is 40, which is C squared. And then I need to do the square root. The square root of 40 is C. Okay, and that is the distance between those 2 points, the diagonal distance. Now, they also wanted us to use the distance formula. So I'm going to go through those steps that I told you in the last example. I'm just going to line everything up. -2, 6. And I'm going to subtract. Okay. So 8 minus 6 is 2. 4 minus -2 is 6. Then I'm going to square. 6 squared is 36, and 2 squared is 4. Then I'm going to add. 36 plus 4 is 40. And then I'm going to square root. So it's the square root of 40. And they just want you to verify that you get the same number both times, because the distance formula is based off of the Pythagorean theorem. Now there's one last type of example. And that was a word problem. And I believe it's number 30 on your homework, where you had a word problem about some palace in China. Okay. I decided to do a basketball court. Now, a regulation basketball court is 94 feet long and 50 feet wide. They didn't give us a picture. I'm going to draw the court, or at least an approximation of that. So it's 94 feet long and 50 feet wide. And they want us to find the distance between one corner and the opposite corner, so across the basketball court like this. Okay. Now, I'm going to erase part of this diagram so you can see exactly what's going on. They want this distance here. I'll label it C. Look at that. If I erase this part, look at the shape it makes. I can use the Pythagorean theorem on that. All I have to do is 50 squared plus 94 squared equals C squared. And I'm going to take that and put it into my calculator, because although I do know what 50 squared is, I have no idea what 94 squared is. In my calculator, I don't know if you can see the screen very well, but 50 squared plus 94 squared comes out to be 11336, which is C squared. And now I just have to do the square root on both sides to find out the length of C. So I can do the square root of that, which is approximately 106.5 feet. Okay, so if you were to run from one corner of your basketball court to the opposite corner, you would run 106.5 feet. So that's it for this video. Please let me know if you have any questions.